So yeah, thanks again, Steve, and everybody at Crunchy and PostGIS Day. All the other presenters have been really fun to watch all the cool things that people have presented. And thanks to everybody who's in attendance here for sticking with us. Obviously, the whole remote conference thing is strange for everybody, but it's been a really good one, I think. And we're really pleased and honored to be a part of it, to have been invited. I am Rob Gaston. I'm a developer at a consulting firm in the San Francisco Bay Area called Farallon Geographics. As Steve mentioned, I'm joined by my colleague Cyrus Hyatt. He is also a developer at Farallon Geographics. But sort of more importantly for this talk, we're both contributors to the Arches project, which is an open source project that we're going to be talking about today. As I'm going through the talk, Cyrus can try to field some of your questions as it makes sense to in the chat, and if we have time at the end, I can also hopefully answer some questions live. Like Steve mentioned, today I'm going to be talking about displaying vector tiles using PostGIS in Arches, which is a schemaless asset management system, and we'll get into why that's important. But I'm going to start with a little bit of project background and history to help understand why the Arches project requires Arches, or it requires PostGIS, excuse me, and what some of the challenges were with actually using PostGIS in Arches. I'm going to take a little bit of time to set that up, but I promise after that will come some more hardcore PostGIS stuff. So bear with me here for a little bit while I set the stage, and then we'll talk about how we overcame some of those challenges with PostGIS and a bit about how Arches projects have used PostGIS. What is Arches? Obviously, probably most of you have never heard of Arches, I would think, and those who maybe have only heard of it, probably have never used it or seen it. It's a little bit of a niche project. So I wanted to start with talking a little bit about what Arches is. So there's the link to the open source project page if you're interested, archesproject.org. And so Arches is a platform for rapid development of asset management applications. So it deploys as a web application, but Arches itself shouldn't be thought of as a web application. It's a platform for building web applications, but its target is not primarily developers. There are ways to customize it via development, but it's really targeted towards domain experts, which we'll get into a little bit. It's open source, like I mentioned. There's the link to the GitHub repo if you're interested. That's another place to get involved. It was originally, or continues to be, managed and commissioned by the Getty Conservation Institute, which is a part of the J. Paul Getty Trust. You might be familiar with the Getty Museum in Los Angeles, which is another part of that same trust, and the World Monuments Fund. And so in keeping with the mission of those particular sponsors, its original purpose was to support managing cultural heritage data around the world. Because of that, it had a requirement for first-class support for geospatial data, by which I mean it needs to support managing geospatial data, but also visualizing them and querying them, etc., just like any other data type. This is especially important in the context of cultural heritage, which frequently you have immovable assets that are in space that you need to track and monitor. And it's built with Django and PostgreSQL as the backend. You might have already surmised the PostgreSQL bit. That is in part because we required first-class geospatial support. So, both of those, both the Django web framework and PostgreSQL via PostGIS provide really, really good support for geospatial data. And it includes a thesaurus management system, which is kind of key to being able to bring this product all around the world. I'm not going to get into a lot of detail of what that really means. I'm going to use thesaurus or thesauri and controlled vocabularies more or less interchangeably. You can think of it as sort of a more sophisticated domain. So, a regular domain allows you to look up values, right? You similarly can do that with a thesaurus, but you can also, a single concept might be represented by many different labels, and those labels might be synonyms, like the words that mean the same thing, or they might be alternative languages. It's key that it has an actual management system. That is not that it just supports the thesauri, but that it actually allows you to manage them in an individual implementation. It uses a schemaless approach to storing business data, which maybe sounds kind of weird, but let's talk about that, I guess, a bit more. So of course, if we're using PostgreSQL as our database of record, that's a relational database. It's not schemaless at all, right? And in fact, Arches does have a schema in Postgres, as you would expect. But when we talk about schemalessness in Arches, what we're talking about is the way that it collects the business data. That is the actual asset data that the project that is implementing Arches is interested in tracking. This schemalessness in Arches is what allows us to provide tools for local domain experts to define their own business data models, as well as their thesauri, et cetera, without requiring a high degree of technical expertise. A lot of the domain experts in cultural heritage are not necessarily experts in databases. They're not DBAs. They're not necessarily web developers. So a big premium was put on trying to empower those people to design their own data models for their business data. And I think to understand how this requirement emerged for the sponsors of the project, it's useful to talk a little bit about the history behind Arches. So I always say, because I think it's kind of impactful, that Arches, that the history of Arches really started with the coalition forces led by the United States invading Iraq in 2003. We now know with hindsight that there was a lot of problematic things that fell out of that conflict, and really horrendous loss of life, etc. Amongst those negative consequences of that conflict was, you may remember, there was a lot of looting that occurred of both museums and archaeological sites. So looting and destruction of antiquities that are really ancient. In that part of the world, they have antiquities that go back thousands of years and irreplaceable. Not only that, these looting operations were frequently used to fund extremism and further exacerbate the conflict situation in the region. So it was a really big problem beyond just the loss of these irreplaceable cultural heritage monuments. The Getty Conservation Institute and the World Monuments Fund, in keeping with their mission to fund projects that preserve cultural heritage around the world, they ultimately developed and deployed the application that we're looking at here on the screen, which is called Mega Jordan. There was also the same product was redeployed for Iraq as well as Mega Iraq. So these started going live around 2008, Farallon was privileged enough to work on these projects for the Getty, but these were not open source projects. This was built as a bespoke application, really suited specifically to the needs of this particular region of the Middle East. Cultural heritage data are highly contextual, spatially contextual, temporally, culturally. All of these things are relevant in terms of how an organization like the Jordanian Department of Antiquities wants to describe and explore their cultural heritage assets. So this product this was a very successful project. It worked well for for Jordan and Iraq, but when the Getty and World Monuments Fund turned and looked at other places where they wanted to deploy this kind of system, so say Egypt or Nepal had some really terrible earthquakes, right? That had similar impacts on heritage. They found that this would not simply could not be simply reapplied to those other organizations or regions, and so that led the sponsors to identify a need for a system that would help these frequently kind of cash-strapped organizations or departments that are tasked with managing cultural heritage around the world, help them know what assets they have, monitor those assets, and make strategic decisions about how to respond to those things. Thus, this new set of requirements emerged. They wanted something that was open source. They wanted something that had this, ability to redefine the business data model. It needed to have support for localization and internationalization such that it would work all across the world. And it needed to have thesaurus management, not simply support for controlled vocabularies, but the ability to actually manage those in the system. And so that's where Arches comes into the picture. The GCI, Getty Conservation Institute, and World Monuments Fund started the project soon thereafter, with the intention of addressing those requirements. And in 2013, version 1 was released, and the current version, which is 5.1, was released just last month. Thanks, Cyrus, for being the lead on that. And Arches is all of those things that I discussed. It's open source and has the ability to redefine the data model and supports internationalization and localization, largely using those the facilities that Django provides for that, and supports the source management. So here is an example of Arches deployed for cultural heritage data management in Jamaica. This is just sort of the splash screen. The intent with Arches is obviously to be applicable to any type of cultural heritage resource. So pagodas in Nepal or tombs in Egypt, or buildings in Los Angeles, and these things are quite different spatially and in terms of their cultural significance. So these are all things that Arches has to support, and does so via this largely via the schemalessness and the support for thesaurus management. Here, what we're looking at is a map, obviously, and that is showing the island of Jersey, which is an island in the English Channel. They deployed their own Arches system for tracking their cultural heritage data, and you can just see already this looks quite a bit different from what we were looking at in Jordan. In Jordan, you have much more remote resources that are much more remote and tend to cover large areas, archaeological sites. And here you can see things are much more dense. It's a small island and it's largely inhabited, so you have quite a bit of density in terms of the actual assets that they're managing there. And that's what I'm talking about when I say that that cultural heritage is highly contextual, or that's one example of it. So what works well in one place just won't work well everywhere, which is why we have this requirement for schemalessness. And Arches is used for cultural heritage in pretty disparate places, like the UK, we saw Jamaica, Nepal, Taiwan, and places in the US. So you know, it's pretty diverse in terms of the cultures and regions that it's trying to serve. An interesting thing happened along the way with Arches, which is that because of the inherent flexibility of this schemaless approach, it emerged that Arches could be used to manage a lot of different types of what you might call asset data, particularly where the relationships between those assets are important. So a lot of you may be familiar with the California Natural Diversity Database. You know, fundamentally tracking species that represent the diversity in California, and sightings, which are the spatial aspect of it, and the organizations that that do those activities, that observe the individual species in space. So one thing that Arches is good at is managing the relationships between those things. And you can see here an example of, you know, a species, Western pond turtle, being related to 3 observations of that species, all of which were observed by the California Department of Fish and Wildlife. So with cultural heritage, as with natural resource management, understanding these relationships is really important for response. So, you know, you have an archaeological site and someone goes out and does a monitoring activity of that, and you want to track who that person was or what agency maybe they were representing. And then later, you know, you might make strategic decisions based on those data. It also has an interesting use case for research where, you know, in academia, researchers might, you know, understand novel relationships between different kinds of assets. So say, you know, Mark Twain lived in this house, right? The house itself might be generally unremarkable, but knowing that Mark Twain lived there and maybe with somebody else or during this particular time period might present interesting venues or avenues for research. Another place where it's being used, honestly, is commercial business asset management. I won't talk too much about it, but the Union Sanitary District, which is a local utility here in the Bay Area, they're using it to manage their bills for sewer service charges to commercial customers. So it's fundamentally the relationship between the bills themselves as shipped, the customer, the fiscal year that it was issued in, and the parcel, which is the spatial bit, right? So it's sort of for the bill, the who, when, and where. And one interesting thing that we do there is we built some custom UI on top of it, leveraging the APIs to present some custom forms and reports. And there's a lot of opportunity for customization in Arches in terms of forms, reports. You can implement custom search logic and interfaces, and you can have, you know, jobs that hook into different events in Arches and custom data types even. So there's kind of a lot of power for developers there, but it also provides a lot just out of the box. So that's what this is, which is getting to the actual data model here. So what we're looking at is the Arches, we call it the designer. This is how you actually design your business data model. So when we say schemaless, what we mean is ultimately what we mean technically is we store this as as JSON in a JSON-B column. But what this designer allows you to do is specify what those JSON documents should look like. And a single resource can be made up of hierarchically related JSON documents, so they can nest basically, which allows you to define a resource as not just like a single flat entity, but as being composed of many entities. So it uses semantics in the graph model, which is also not something that I want to really talk about too much here, but it is powerful when it comes to interoperability. ArcGIS has support for ontologies. It doesn't require you to use an ontology, but you can, and it ships with a particular ontology called the CDOC CRM, CIDOC-CRM, conceptual reference model, I think. That just has, semantics, it's a semantic ontology that you can apply to your data. And what that really gets us is interoperability with other systems that support linked open data. So we do that via a format called JSON LD, which expresses data in a semantic way. That's important, particularly for the project sponsors, because they want ArcGIS to be able to export data in a way that is self-describing. It's expressive in its structure. It should be interoperable with these other systems that they have, and then they ultimately want it to outlive the system, because frequently these are data that are representing things that maybe are thousands of years old. Hopefully will continue to be around for hundreds, if not thousands, of years of human future. So they want to have the data be the thing that can live on. So here now what we're looking at is the sort of an example of the flexibility. On the left, we can see these are sort of just contrived place resources, right? On the left, we can see there's a Geojson feature collection node. So we collect our geometries as Geojson, which we'll talk more about in just a moment. And it has an accuracy value associated with it. And that accuracy, as you can see in the label there, implies that it's just always represented in meters. But if another project wanted to instead represent that accuracy in different ways, they might add a separate node to track the units. So then you could track accuracy in meters or in miles or whatever. So now what we're looking at, that was the designer, right? And now what we're looking at is the actual, we call it the resource editor. So this is the default user interface that you get out of the box for managing your assets in ArcGIS. And this is just all automatically generated by the system based on the schema that you defined, quote unquote, for your resource models, as we call them, in the designer. And you can see here, that just by adding that node for units, this new field shows up in the form to add units. And below the screenshots, what you're seeing are the actual JSON documents that we store for these particular forms. And I'm sure you will note that the geometry there is a Geojson feature collection, and you might be wondering how then we take advantage of ArcGIS, or maybe you watched the talk earlier today that largely revealed some of that. PostGIS, PostGIS is really a key technology in ArcGIS. We use it for a lot of things, and as everybody here knows, it's just great. One thing that we do a lot with, which is the main thing I'm going to talk about today, is rendering vector tiles. As Steve mentioned, we have had support for serving vector tiles built into ArcGIS for a while now, and it's evolved over time. And I'm going to show how STS MBT really changed the game for us when that came around a few years ago. We also use it for presentation of sort of related layers, I guess you could say, for basic geospatial data processing and querying capabilities, which it's obviously great at. And then also, which I'm going to talk about at the end, interoperability with desktop, or what you might call traditional GIS software, which is always a fun thing. The way that we actually access our PostGIS or our JSON data via PostGIS is to use a materialized view to convert those GeoJSON feature collections into a flattened representation with actual PostGIS geometries attached. I thought since this was a database conference, I would throw some SQL at everybody here. I'm not going to go into too much detail here, but you can see how this view really relies on the intersection of JSON querying and the capabilities that PostGIS provides in terms of functions to actually recast and transform geometries. The other sort of important bit about this is we made it a materialized view specifically so that we could take advantage of what you see on the last line here, which is a geospatial index. And that is how we're able to actually do things with PostGIS against this view in a performant way. And so this materialized view is really the key that unlocks the capabilities of PostGIS in Arches, despite the somewhat idiosyncratic way that it manages and stores the business data. So this is just an example of how with this materialized view, we're able to use off-the-shelf tools to query and visualize our geospatial data, which you can't do when it's all wrapped up in the JSON. So here's here's an example of using pgadmin, I guess, to do that. There is a gotcha here, which is that it's a materialized view. So that means the view has to be refreshed by a SQL command. Depending on the scale of the project, that can happen synchronously or asynchronously, or it may be better to do in a job, in like a nightly job, if you can live with the latency there. But understanding the requirements for latency for geospatial data layers against data volume are kind of the things that one would need to look for to make that decision about how to actually manage refreshing the materialized view behind the scenes. This slide shows a process that probably a lot of you are familiar with a little special sauce here, which is how we query and serve vector tiles for our web app. So on the left, you can see a web browser, is trying to render a layer. That URL structure probably looks familiar to most of you, at least the last bit there, the last line with the regular kind of ZYX parameters built in. So the web browser needs this layer, and it issues a request over to what we call the Arches MBT API. And that's the tile server that we built that Steve mentioned earlier. It's really just a Django view that wraps up that creates a service that returns data from our materialized view as vector tiles. And the way that we do that is the view is responsible for parsing the incoming parameters, and it uses, this is a little bit simplified what I'm showing you here, but it uses our database connector to generate a little SQL query, and that SQL query is then issued to our PostgreSQL database against our materialized view, and it uses that st as MBT function, like I mentioned, which in rapid order returns a nice wrapped up vector tile as the result, and the MBT API ships that response back to the browser just as is. It's a PDF vector tile ready to go, and then the browser is able to render that. There's a little bit of extra stuff that happens in the middle, wherein we use Django's default caching capabilities to actually cache vector tiles, just like we would anything else that we cache via Django. That's one really nice thing about this implementation. Prior to the availability of ST as MBT, when that came online, I guess maybe 3 years ago or a little longer, we did have this same MBT API. Well, it wasn't the same, but it was a similar MBT API. It still used PostGIS and the materialized view, but to actually cast the data to vector tiles, we used a product called TileStash that some of you may be familiar with. This seemed like a reasonable candidate, given that we're working in Django and TileStash is Python based, and it fit in reasonably well, good enough for the time, I would say. But there was definitely some issues. The support for vector tiles was not like a first class feature in TileStash. It was sort of an add-on. And the support was not great. The tiles would get rendered with an older version of the MBT spec. At some point, that kind of, Mapbox GLJS, which we use on the front end, sort of had moved on from that version of the spec, and sometimes the rendering would get a little wonky. Performance was not great, and the implementation was pretty complex because we were calling out to this what is really meant to be run as its own separate application, but from within a Django view. And that also required us to use TileStash's internal caching capabilities rather than Django's native caching capabilities, which was not ideal. So yeah, PostGIS ST as MBT function really dramatically improved all of those things for us. It's a much simpler implementation. We can use native caching. It's I think, really great from the project's perspective. Another way that we've used PostGIS in Arches is to display what you might call just data layers. A lot of Arches users have geospatial data resources in-house. They maybe even have GIS staff in-house that maintain some of those things, but frequently they'll lack the infrastructure, to serve those things up in a web service. They're not equipped to set something up like PG TileServe necessarily, and so an approach that we've taken to try to help those organizations leverage those data inside Arches is to just load those data directly into the PostgreSQL backend for Arches and serve those up as vector tiles. And we've done that in a couple of ways. We've either done that writing a custom Django view that looks very similar to this one that we see in this previous slide. Sorry, now I have to go back to that. The other way is to just stand up an external geospatial server product and serve it through the web app in a way similar to what Paul Ramsey was talking about earlier. So you could use PG TileServe, and we have, or whatever other products that are maybe not as good, like GeoServer. Good in ways, but PG TileServe is really great. So that's sort of the way that we've tried to help those organizations that maybe don't already have like a geospatial server or a sophisticated enough GIS team to support that kind of infrastructure. And then what we just serve those data up as layers in Arches. So here's an example of a parcels layer being shown in Arches. That's not actually the data that are managed in Arches, that's just shown for context in this particular case. And like I mentioned, finally I wanted to talk about a little bit about how we use PostGIS to drive integration with traditional or desktop GIS software. Like I said, a lot of the institutions that have implemented arches, particularly these smaller sort of cultural heritage management organizations, they maybe have GIS software licenses and a few people in house who know how to use them. And those people, as probably most of people who are trained GIS professionals tend to be pretty opinionated about their toolkits that they want to use, particularly with regards to managing geometries. So a thing that the project kept hearing from users again and again was that they had GIS users who wanted to be able to manage geometries in whatever desktop GIS software they have in house, and 9 times out of 10 that is Esri ArcGIS Pro. But here's a more fun thing to look at, QGIS. So one way that we've managed that using PostGIS is with QGIS you can just create a direct connection, direct database connection to PostGIS and pull either our that materialized view that I showed, or other data layers from the Postgres database directly into QGIS. I say other data layers because the materialized view is really pretty simplified for performance, etc. So it only really includes that geometry column and then additional identifiers that are required to query subsequently for additional related data. So so one approach that we've taken to try to work around that gotcha is just building additional views on top of our materialized view. So that allows us to conflate additional data onto a layer for presentation or use. Oftentimes you might want to visualize on some property in your GIS. So for example, in London, they're tracking architectural heritage buildings, old buildings, and those buildings have different classifications for how they're managed. So that's frequently a thing that you would want to be able to visualize that data layer on. So, we help them write a view that leverages the materialized view and in turn conflates on some additional data, that classification information as a property so that they can then, use that in their GIS alongside these geometries. I guess the other gotcha about this approach is that these views are read-only. So you can't manage your data via these means because it's really just in a materialized view. In addition to our MBT API, which I talked about earlier, ArchGIS also provides a Geojson API, but it's a bit of trickery, I guess I would say, in the sense that ArchGIS already stores geometries as GeoJSON. So this API actually bypasses PostGIS and just returns GeoJSON straight out of the ArchGIS JSON column, which does limit it pretty substantially because you can't do direct spatial processing or querying via this API. You can, retrieve GeoJSON from this API and then process it after the fact in some sort of a GIS software. But the GeoJSON API is really it's mostly used as a dump of data. So it, if you want to just quickly dump out a set of resources as a data layer, as a GeoJSON, and then load that into some software, like you could easily load that into QGIS or most web-based software. So it's useful for that, but it's in terms of performance and frankly in terms of usefulness, I think the MBT API is quite a bit better. Finally, I guess I wanted to talk about something cool that the project did recently. where we kept hearing, like I mentioned, we kept hearing this request from teams who had GIS professionals on staff, trained. They use some particular GIS software on a day-to-day basis. They know it and love it, and they want to be able to use those, high resolution, high quality geometry editing tools that they know and love to manage the geometries that are stored in arches. So that, as it turns out, is a pretty tricky problem in the world of ArcGIS Pro. But the team was able to facilitate this, largely building on top of the APIs that I was just describing. So the team built this add-in that actually allows you to add Arch's data layers to an ArcGIS Pro map as feature classes, and actually use the ArcGIS Pro geometry editing tools to edit that geometry. And we then use the Arch's APIs for managing data on the back end to ship that geometry back to Arches and update it, in the PostgreSQL database. So there's kind of a lot happening with the various geospatial APIs and APIs for managing business data in Arches via this add-in. But it really filled a specific need that we heard expressed by these organizations that had desktop GIS users in-house. So I thought that was kind of a cool, it kind of brings it all together, I think, in a little bit of a way. And yeah, that's it for me. Yeah, thanks again to everybody. And I think we might have time for questions. I don't know, Steve, you let me know. At the bottom there's links for the open source project and for our GitHub repo. Like I said, it is open source. So whoever's interested in the project can check it out and get involved if they want to. And yeah, thanks again.
Thanks, Rob. So people go ahead and ask your questions if you want in the Q&A or the chat or in Discord. I kind of had a question about training the users. So it looks like you're using like stored procedures and you're using like some more of the advanced features of PostGIS or PostgreSQL. How did you find it training the users to kind of do some of that stuff on their own? Do they work through support with you, or do you think they've picked it up before? Or
you're talking about specifically when it comes to leveraging, like actually using this materialized view in PostgreSQL to write other views, like I was describing, those kinds of use cases?
Yeah, like because I think writing views is, there's a lot of Postgres users who never have written a view, right? And I don't know, do you let them write you wrote your own user-defined functions for MBT streaming, but can they actually go in and write, is the database a black box to them, or are they allowed to write their own functions if they want?
No, they definitely can, and it varies, the level of sophistication and even just resources that an organization has to be able to actually tackle those kinds of things. So we've seen it both ways, where organizations just don't have the in-house capabilities to do that kind of stuff, and they really need to get some outside help to work with the database. And then there are organizations, like English Heritage in the UK. They're pretty well funded and have a lot of resources, and they have developers, and they've largely been able to do a lot of that on their own, just reaching out to the community directly, the open source community directly, and that it's a pretty vibrant community in that way.
Right. You mean around Arches, the vibrant community?
Yeah. And the community is pretty varied. There are organizations that have more technical expertise, like English Heritage, and then there are organizations that really lack it, and kind of everything in between.
So on those in-between ones, how do you approach training with them? Like to get them, I'm assuming most of those in-between ones are also probably the ArcGIS ones. Is that true?
Yeah, I think that is generally true.
And we could, it doesn't have to be ArcGIS, right? We could say they're desktop GIS users, right? So they're not really, usually they're not very comfortable moving away. If they can't point and click it, they're feeling very uncomfortable. I mean, how do you approach training them like that?
It's less, I think, an issue of technical training and more, I think, an issue of like trying to help people get over biases, maybe. And that is, I think, tricky. I think the community is a lot of what has helped people feel more comfortable with that, because it's not, you know, there's a whole community of people who are using the software. You know, it's not like you have to come to Farallon or the Getty or you know, someone who owns the thing, you know, to try to understand it. And that has helped in some ways, at least to the organizations that are open to open source. But then we all know that there are organizations that are just very close-minded about that question.
Yeah. But they're still willing to use arches, even if they're close-minded to that. But it's not for open source reasons. It's because this piece of software does what I need it to do, right?
Yeah, some have, and that's largely because the cultural heritage domain has just been historically very underserved. So there's not a lot of other options on the table.
Right. It's not like oil and gas or telecommunications or road networks.
Exactly.
Right? People aren't coming. Like, here, I just got a grant for $500 million and I need some software. Oh, here, take a couple million.
Unfortunately, it tends to be the kind of thing that people don't really worry about and throw money at until something really tragic has happened. Like, you know, with the story behind Mega in Iraq.
Yeah. So there is a question that came in from Karsten. He's asking, how customizable is Arches to use as a more general web mapping framework other than historical asset management? So you showed the CMDDB, right?
Yeah.
That was managing bioresources. So that's a little bit different, right? Do you have other examples of stuff like that you can talk about?
Yeah, well, I touched on the USD example. I didn't want to like foreground that too much and get away from the cultural heritage stuff, but yeah, it's used for really completely separate domains. Another kind of interesting example, I mean, you know, the Getty early on was, you know, all about cultural heritage, as using arches for cultural heritage, and trying to promote getting these kind of, you know, different international departments to adopt arches and use it to maintain their data. But as time went on, they realized that a lot of the requirements for cultural heritage data also applied to scientists that they have in-house at the Getty labs, who are doing work, you know, studying art and antiquities, and you know, they actually have to they take a sample from some particular artwork or whatever, they run it through different instruments, they get back data. It's not the exact same problems, but it's a similar set of problems, right? Because you have an asset, you have you know, related data about that asset, you have an individual who represents some organization and they've, you know, collected a sample, and you know, you have instruments. So these things are assets, and it's fundamentally about managing the relationships between them. So use cases that have that, you know, those kinds of things, I think, you know, you're trying to manage some kind of assets and the relationships between them. Arches can pretty readily be repurposed for those. That is not a out of the box kind of thing, I would say, with arches. That's a developer, you know, thing. But we have a way where you know, there's the arches product, and then there's what we call arches projects. And arches projects are basically like, you know, a particular kind of implementation that could be deployed for different kinds of organizations, if that you know, suits their needs. Or they could fork that project and customize it further.
Right. So it's almost like you have a space. Another way of thinking of it is almost like you have a spatial document management program also, right? Like it's again, like you said, you use the term asset very loosely. It's a thing, right? You have a thing, and other things have either people or other things have relations to it, or there's an article about that thing or something, and you want to track it and keep track of the relationship. I mean, I think the other thing that you pointed out that a lot of companies struggle with is also I know it scares everybody away. It certainly scares me away. I don't really like using the word ontology, but That controlled vocabulary though, and also mapping this word to that word, especially like, there's a thesaurus, we have a thesaurus in the geocoder built into PostGIS because of that exact problem. Like what's a street, what's a way? OpenStreetMap has that kind of problem too, right? So I think that projects that probably need a good thesaurus or a word mapping would also probably benefit from something like Arches too.
Yeah, that was one of the big overlaps between the cultural heritage use case that the Getty and World Monuments Fund started with, and the science use case that the Getty later had emerge. Right. Is that need to enforce ontologies and support for controlled vocabularies.
Right. Okay.
There's no. Oh, go ahead.
No, go ahead, Cyrus. Go.
I was just going to say there's no fundamental difference in terms of how difficult it is to set up an Arches project between whether it's cultural heritage or anything else.
Okay.
It's fundamentally the same.
Okay. It's basically you're just customizing interfaces or customizing stuff like that. Is that basically what you would do? Yeah.
Yeah, but out of the box, it's not. You could use it for anything. It's not really.
Right.
Yeah, it just happens that the Getty has put money into funding particular projects, like I said, for cultural heritage and science. But those aren't core Arches. The core Arches software. Those are projects that are built on top of it that could be repurposed for those same verticals, I guess, if you will, if it made sense for the particular organization.
Right. And I do think much like Alpash's talk, you guys also showed the flexibility of using PostGIS for a lot of different things, right? I know you guys use like Elasticsearch and other things, but you've actually, the flexibility again of Postgres has enabled you to, minimize your stack in terms of
what you needed. And that was what the eliminating tile stash thing was all about. That was a great day in the lives of Arches developers when we got to just go native PostGIS.
Okay, great. Thanks, you guys.